Hi everyone, welcome to another video. In today's video we are going to solve house robber 2 problem from the Leetcode. In this problem they will give an array of numbers which represent the amount of money available at each house, and a robber needs to rob these houses. We need to return what is the maximum amount a robber can rob with the given conditions. The given conditions are: robber cannot choose to rob two adjacent houses. That means if a robber chooses a house at index I, he cannot rob the house which is present at index I plus 1 because I and I plus 1 are adjacent to each other. And one more condition in this house robber 2 variation of this problem is houses are present in a circular manner. This means first house and last house are adjacent to each other. If robber chooses to rob the first house, he cannot rob the last house because they are adjacent to each other. If robber decides to choose the last house, then he cannot rob the first house because they are adjacent to each other. With this understanding, we can solve this problem using three techniques. The first technique is recursion, and the second technique is memoization, and the third technique is dynamic programming approach. I have created a video for house robber 1 problem. I have given link in the description. You can go through that video in order to understand how to solve this problem using recursion and memoization technique. In this video, I am going to discuss dynamic programming approach in order to solve this problem. Let's write the code in order to understand the technique that we are going to use. First thing that we are going to do is we are going to do some sanity checks before proceeding. If num size is 0, then this means robber cannot rob anything, and in this case we have to return 0. And another sanity check is, what if there is only one house which is present in the given problem? If there is only one house, then robber can rob that house, so nums of 0. And what if there are only two houses? If there are only two houses, then robber has to choose maximum between those two houses. Consider a scenario where there are only two houses which are present. He cannot rob both of them because those two are adjacent to each other. Then he has to choose between the maximum amount between those two. So return max between nums of 0 and nums of 1. So other than that, robber has two choices. First thing is robbing the first house. If robber decides to rob the first house, then he cannot rob last house because those two are adjacent to each other. So the first vector that we are going to get out of this condition is v1. We are going to create a vector from the given nums, that is nums.begin. So it represents from where our current v1 starts. Since robber is robbing the first house, he cannot rob the last house, so nums.end -1. So this creates a vector from the first element except the last element. And the second combination robber has is robbing the last house cannot rob the first. So in this scenario we will get a combination like this: v2 will be equal to, we can create a vector but we cannot choose the first element, so nums.begin +1 and nums.end. So now we have v1 and v2. Now robber can choose houses from these v1 and v2, and he can return the maximum value that he can rob. Return max of, we have to implement this function as well, max rob of v1 and max rob of v2. So this max rob function will be exactly same as house robber 1 problem. So we will get a vector of integers. We are going to take that as a reference, and first thing that we are going to do here is we are going to create a vector of size nums.size. I'm going to call max possible rob, and it will be of size nums.size. Now we have created this max possible rob. We have to start filling in the base cases. So what is the max? If robber is allowed only to rob till index 0, then what is the max possible value? Max possible rob of 0. This represents the maximum amount robber can rob if he is allowed to rob only till index 0. So that is nums of 0. And what is the value? Max possible rob of 1. This represents the max possible value that a robber can rob if he is allowed to rob only till index 1. So that is maximum between nums of 0 and nums of 1, because he cannot choose both of them because they are adjacent to each other. And for the remaining values we can generate using previous values. For int I equals to 2, I less than nums.size, I plus plus. So what is the max possible rob of I? So here robber has two choices. Max between either he can choose to rob the current index, that is nums of I. Then if he chooses nums of I, he cannot choose the max possible rob value at I minus 1 because I and I minus 1 are adjacent to each other. So he has to choose max possible rob value at I minus 2. And the second choice robber has is he can skip this particular index and he can choose max possible rob of I minus 1. So these are the two choices robber has at every index I, and after that we have to return max possible rob of last index, because robber is allowed to rob till the end of that array. So nums.size minus 1. So we have already taken care of first and the last house using these two vectors, where we decompose the problem into these two problems, and solving these problems is exactly same as solving house robber 1 problem. Let's submit the solution and check whether it passes all the test cases or not. Yes, as you can see here, this solution is passing all the test cases. If you are interested in learning more about dynamic programming, data structures and algorithms, you can check out other videos from my channel. Thanks for watching this video.